This is part 2 of my DIY 3D printable wall art design made in Blender. To see the entire Blender workflow, watch part 1 linked in the pinned comment and video description. In the first tutorial I created this in Blender. Now let's finish this up inside of Blender, prepare, export, slice, 3D print and finish this wall art / sound diffuser panel. Please like the video and subscribe to this new channel, Crispy Tech, so you never miss a video. Thanks to Bamboo Lab for sending out some white marble PLA for this project. I bought the X1 Carbon last fall and I love that machine. You can find my Bamboo Lab affiliate links in the video description. By using those links, when you buy a 3D printer or filament or accessories, you can support this channel without any extra cost to you. Thanks again to Bamboo Lab and thank you for your support. Okay, this is what I have from the last tutorial. And before we start cutting this and then preparing everything for 3D printing, I want to change a few things around. First of all, if I switch on wireframe here, you can see that this bevel going down only halfway kind of messes up this geometry here. I don't like it. I'm just going to put on a bevel just on the top, which means I just move the bevel to the top and I keep this on vertex group just at the top. And then the subdivisions we can crank up to 3. Next thing I want to do, I want to go through the shape keys real quick and see what we got. So the first shape key is this hill here. Let's bring this up to, this looks good. The second shape key was this one here, I think. This could be a little taller too. Look at it from the front. Yeah, something like that. Then the third one was taking away some out of the middle here or going diagonally here. I think I'm gonna edit this one a little bit. Okay, so let's see. We got this and then we have some in the middle. So if we go into edit mode, for example, this one, maybe even the one on the end here, this one, there's some stuff sticking up here. This. Okay, let's take these, and then with proportional editing, we go G, C, maybe make this a little smaller. Okay, like that. And then that should give us a better result here. I had some stuff sticking out here that I didn't like. And now it looks a little bit more uniform, I think. And I'm gonna go 0.75 or something. Okay, next, what does this one do? Oh, this is the twisty turny one. So let's see, take this down just a little bit so we don't get extremely distorted spikes here. And then what else do we have? Number 5, that was this one down here. Okay, I'm gonna take this down quite a bit. Something like that. With this, I will apply all of the shape keys. Why? Because then I can apply all the modifiers. Okay, so let's save first, then apply all the shape keys. So now the shape keys are baked in, and now I can apply the bevel, and I can apply the subdivisions. Okay, so this is now baked in mesh. And if we look at it from the front, and we zoom in all the way here. Now, if we put this onto the slicer might decide, okay, this is a really tiny spot here. I might print just the first layer continuously. Or it might go, well, I'm gonna print this, then leave a gap here, and then print over here. How do I know this? Well, I tried it. I put this in the slicer, and I got some areas with gaps and some areas where it was just one continuous first layer. Okay, I don't want gaps because I want to have one printed piece. And so I will add a 1 millimeter of just base down here to everything. Now I want to select the bottom, so I go to face select mode, select this one, and then go select similar, normal. That should give me all of the faces on the bottom. And then I can just extrude this down, and how far? I'm gonna enter on the keyboard 0.001, which is 1 millimeter. So now everything should have a little bit of a base, and then if we slice this and print it, then it's kind of obvious for the slicer what to do. It will just print continuous 1 millimeter thick base. Perfect. Okay, now next thing, I need to cut this apart into pieces. So for my prototype, I printed all of the spikes individually. And now I'm gonna print chunks of this. So I'm thinking 4x4. So 4x4, something like this. And then hit Ctrl L, which selects all the connected pieces. So this should be one chunk that I can put onto the slicer. Remember, this is 4 centimeters, so this would be 16 centimeters. And with stuff hanging off, this should fit nicely onto the 25 by 25 print bed of the Bambolib X1. I might be able to fit a 5 by 5, but then I will just have 5 and then 4. So I will just have one row of this, which makes no sense. I don't know. I'm gonna go with 4 by 4. So really what I'm gonna do is something like this. 4. So this is gonna cut down the middle, and then 4 is gonna cut down here and here, and then 4 goes over this way, and then 4, and down here I'm gonna have 4 by 3 chunks. Okay, so I will have 12 pieces, probably 12 print beds. So now let's cut this. Okay, just like I said, select this, Ctrl L, and then P, separate by selection. Okay, and then select this, Ctrl L, P, separate by selection. And you can see we're getting individual parts here. So if I go out of edit mode, let's switch off wireframe here. So now this is a piece, and then the rest. And I will just have to do this for all of the pieces. So in edit mode, select Ctrl L, P by selection. Select P selection. No, sorry. Ctrl L, P by selection. Okay, now we could export each piece as an STL file individually, or we can just export the whole thing into one STL file and then rip it apart in the slicer, which is what I'm gonna do. However, I already tried that too, and I know that the slicer sort of has problems if these pieces are stuck together like this. So instead of this, I'm gonna delete this. So instead of having them all stuck together like this, I'm gonna move them apart a little bit. So if I move this, whoops, I still have proportional editing on. So I'm gonna move this out a little bit like this. And then just take it apart a little, so that they are really obviously distinct parts. And then the slicer is gonna know how to cut this apart. Okay, we did rip this apart into chunks, but if we go into edit mode and we select one vertex and hit Ctrl L, we can see we still have individual spikes. We want this to be one solid part, all connected by this 1 millimeter thick base plate here. How do we do that? Well, how about we select this, and let's see, and we go mesh, clean up, merge by distance. So it should merge these vertices where we have several in one spot, down here, and merge this into one. So if I select one vertex now and hit Ctrl L, it's selecting the entire chunk. Okay, now we have to do this to all of these, and that's really easy because we can select all of these and go into edit mode for all of them, select all, mesh, cleanup, merge by distance. Okay, so if I go over here, Control L, this is now a solid chunk. Okay, cool. However, if we think about this, now we merged these vertices by distance, but I think we're gonna end up with internal faces here. So let's look inside. And yes, we have internal faces here. So between this spike and this spike, down here, we have an internal face, which you can see. How can I make this so we can see it? You can zoom in like this. And then there's this face in here, right? This shouldn't be in here. There should be a continuous volume and no faces dividing the different spikes. So how do we fix this? Well, we just go to a mesh. Now we go to select interior faces. Well, that's that. Okay. And it selected all of them since I'm in edit mode for all of the objects at the same time. So let's check it out. So here we can see the internal faces. And now we can go X and we can dissolve the faces, which dissolves the individual faces and just leaves one or simple single faces. And then we can go X only faces. And that deletes the interior faces. However, if we go to edge select mode, we still have those edges now, which might not be a problem for the slicer, but I think I want to get rid of them anyway. So how do I select these? You go to select all by trait, non-manifold, and it selects those edges that we don't want. And now we go X, edges, and then if we look inside, we should have a continuous solid volume that the slicer can now print. I think I'm done cleaning up. Okay, so let's go back out to object mode. Now we need to export this into an STL file for the slicer. I'm gonna select everything and then go to File and Export STL. I'm gonna go print 3. I've already done some tests. Selection only. Scale is 1000. So by default, this is going to be scale 1 when you first export something to STL, and you should always enter 1000. That's just the difference between Blender units and other units. I don't know. It's just one of those things. Export print 3 STL. Okay, now let's jump over to Orca Slicer. Okay, here I am in Orca Slicer, and I'm just gonna drag and drop print3.stl, which I just created in here. Of course, this is now too big, but this is one object, and I can just hit number 4 on the keyboard to assign the 4th material in my AMS, which is the white marble that Bamboo Lab sent over for this project. Thanks again to Bamboo Lab. Okay, now how do we put these onto a separate print plates? Well, that's really easy now. We right click, split two objects, and then the slicer rips this apart into individual objects. So we just have one STL file. We didn't have to go export 12 times. We just did one export from Blender, and now we ripped it apart inside of the slicer. Let's see if all the objects are good, or if we have anything dangling around. No, this seems pretty good. Now how do we arrange this? Also very easy. Orca Slicer has this awesome button, which is auto arrange. You just click arrange, and then it creates 12 or actually 11 individual print plates. Why 11? Because it put these two onto here. Okay, this is awesome. I think we can optimize this a little, because the slicer always puts it right onto the edge, which I don't like. I'm gonna go like this probably. Just bring it in a little bit. They can be closer here, and then they're not all the way out to the very edge of the print bed. Okay, now this is already ready for slicing. So what are the slicing settings I'm gonna use? I already have the white marble. I'm gonna use 0.28, which is the extra draft layer height. Okay, so I'm using the tallest layer height for the 0.4 nozzle. Then I think I'm gonna use one walls loop just to print just the outer wall, almost like vase mode. I just want one perimeter. And then let's see what else. Well, let's just try slicing one plate here. So let's take this one, slice plate, and see what we get. Okay, so first of all, we really don't need the brim. Brim type, no brim, which is in the others section here. Let's slice again. So we're gonna get this base. And then the spikes start. We have all of this infill. We don't need this. This is way too much filament, and it also takes way too long to print. We really don't need any infill. We only have one outer wall loop, and then we can set the infill, sparse infill pattern to lightning. So what does that look like? This is a really cool infill type, especially for stuff like this. It basically prints hollow spikes now. But as you can see over here, for example, it starts printing this stuff that looks like lightning, I guess. And it builds up these support structures, internal support structures, so that it can support the top and lay the top onto that support structure. But other than that, all of these spikes are now hollow. So this is like the least amount of infill, the least amount of filament, and also the least amount of weight that we can generate here. However, there's one thing I want to try here, and that is printing this with fuzzy skin on the contour. I have never tried fuzzy skin with just one perimeter, and so I made a test print. It came out great. It's extremely lightweight, uses an absolute minimum amount of filament. The fuzzy skin not only hides the layer lines, but also gives it this really nice surface texture. And I'm sure printed in Bambu Lab's white marble PLA, this is gonna look fantastic. So I enable fuzzy skin contour, no brim, and over here I just print one wall loop and lightning infill. And these are my settings for printing this. So here is my Blender made wall art / sound diffuser panel, which is 70 by 50 centimeters and has 176 3D printed spikes on it. Designing this in Blender was a lot of fun. If you haven't seen that video yet, do check it out on the other channel. Link is below. Printing on the Bambu Lab X1 Carbon went mostly without hassle, but almost 180 of those spikes with fuzzy skin did take a total of about 40 hours printing time. Even on the blazing fast X1, yeah, especially the fuzzy skin is much slower than just straight lines. But it's totally worth it. After printing 2 build plates without any issues, the third plate failed with a nasty nozzle clog, and after fixing that, I switched to the 0.6mm nozzle, thinking maybe the marble filament with the darker particles inside had something to do with the clog. And with the 0.6 nozzle, the other 9 build plates printed beautifully and faster. Another interesting stat: out of 40 hours of printing, about 4 hours is just travel, where the print head moves from one area to another. And it does that at extreme speeds, by the way. But still, 10% of the time is just travel. And this is now only 1,400 grams of filament due to just one perimeter and lightning infill. By the way, I simply used regular all-purpose glue to stick the PLA pieces to the canvas. Please let me know what you think about this Blender and 3D printing project in a comment down below. This is my new channel, Chris P Tech, where I show many other things I do besides Blender. Please subscribe to both channels. Thank you. The blend file and also the STL file of this is also available at patreon.com/crispy. This project is possible because of these fantastic people. And thanks again to Bambu Lab for sending out some of their white marble filament, which looks awesome. Thanks for watching, subscribe and support below. See ya.